Hello everyone. I'm Semagana Trevor, a year two student at Makerere University, pursuing a bachelor's degree in software engineering. And I've come to talk about the laptop price predictor system, which uses AI in its daily operations, as I'm going to show you guys further as we move on. As I start, I'm going to give a brief overview of this system, but before I do that, I humbly and kindly request for you guys to kindly subscribe to my channel as it's a new YouTube channel, such that you get notified of the daily notifications that and the daily content I will have to post on this channel, and then like my videos. As I start, a laptop price predictor system is a system that can predict the tentative price of a laptop based on the user's configurations. What do I mean by that? That this system will prompt a user to insert in details of his or her specified laptop of interest. And what this system will have to do, it will be able to predict the price of that laptop. Many people face the challenge of knowing what they want, but not knowing how much or what they need to get it into their possession. That is this challenge is what this laptop price predictor system has come to solve. People are there that know that I need this kind of laptop, but then they don't know how much they need to solve or to get this laptop. And this is what brings in scammers and other people with negative intentions that come to charge these people. They charge these people high prices. You see, they charge people high prices and end up like selling to them laptops of low price to at high prices. That's that they get what they want. That is what this system has come to solve. That is what my fourth point on this slide says. This is to help many people from being scammed by other people who take advantage of the pre-users' ignorance on the prices and end up charging unrealistically high prices as compared to the exact price of the item in the current market. Mm, the application of AI in or the application of artificial intelligence in the LPP system. Artificial intelligence enables computers to predict certain outcomes based on the large amounts of data. So artificial intelligence is all about prediction. And this is how it is applied into my system, whereby it enables the computers, because computers are obviously going to run this system. So it enables computers to predict certain outcomes based on to predict the price, because this system is going to predict the price. So to predict certain outcomes like the price of a laptop based on what the user has inserted into the system. Um, so when a user feeds in his or her data in the system is able to predict the price of the laptop of the user's interest, which brings in artificial intelligence. Artificial intelligence picks from the large data set of data um, the most appropriate laptop and its price depending on the user's interest and displays the price to the user. Types of data used to solve the laptop price prediction problem. Firstly, the LPP system uses different types of data. Don't get misled, I wouldn't get lost. When I say LPP, that's the laptop price predictor. LPP system uses different types of data which involve string or text, numeric, alphanumeric data while in its operations. It uses string data type in the inputs of company, because company is an input in this system, which is Dell, like HP, Dell, Asus, Lenovo, the type of laptop, which is like notebook, gaming, ultrabook, and many other. The system also uses numeric data, which is like in the fields of screen size, 13.3, 14, 15.6, 17. Those are all screen sizes, and that is numeric data. Also uses alphanumeric data in the fields of weight, like 1.37, that is numeric, and then kilogram or kg, that is text of string, or alpha. CPU information like the i5 2.3 gigahertz, Intel is string, core is string, I is a text or a character, and then the 5 and 2.3, those are numerics. Differences between supervised and unsupervised learning, as they are both under types of machine learning. First of all, under supervised learning, it uses labeled data to help predict outcomes, while unsupervised learning uses unlabeled data to help predict outcomes. Supervised learning helps in image recognition systems, text prediction systems, spam filtering, and many more. while the unsupervised helps in movie recommendation systems and ranking systems. And that is the second difference I have. Thirdly, supervised learning involves first training the model using the inputs. It involves you first train the model under supervised learning. You have to first train the model because under supervised learning, we always have what we call historical data. That's what trains the what we already have data input to help this model to come up or cope up with the output it has to give to the user. While under unsupervised learning, it involves inputting unlabeled data to the model, whereby we don't have any, just unlabeled data. We don't have any like previous data that we have to use to feed into the system or to feed it to the model so that it copes up with the way it has to run the tasks. Those are the differences between supervised and unsupervised learning. And as I move further, we have what we call the supervised learning techniques. Firstly, we have the classification technique, and this is used to identify the category of new observations on the basis of training data. And under this technique, we categorize data into a given number of classes. And the major aim of classification problem is to identify the category to which new data will fall. As you understand, under supervised learning, we don't have we have data. We already have data to use, historical data that is used to train the model. So this classification helps to identify the category to which this other new data we have to use this other new data that's going to be output by the system. It helps to identify the category to which that data is going to be stored or to which that data is going to fall. Then in real world, this technique is used to classify spam into a separate folder in the inbox, linear classifiers, support vector machines, decision trees, and many other applications. We have the regression technique under supervised learning, which is the technique of machine learning that helps in mapping predictive relationships between labels and data points. In simple terms, this technique is used to predict continuous values, and these values are not discrete values or they're not permanent or static values. They change. That is continuous values in supervised learning technique. This technique helps to find the relationship between dependent variables and independent variables, whereby the dependent variables are the output and the independent variables are the input, which are in supervised learning. It also consists of finding a mathematical relationship between the measurements of two variables A and B, so that the value of variable B can be predicted from the measurement of variable A. When we go to unsupervised learning techniques, we have what we call clustering, which is the process of grouping similar entities together. It involves discovering natural groupings of unlabeled data. Since we use unlabeled data in this unsupervised learning, clustering, it just helps to group this unlabeled data into different groups. It's like kind of classification in supervised learning. And this technique is helpful in market segmentations, image compressions, and many others. Also have association, which is the technique where algorithm tries to learn without a teacher, and that's all about unsupervised learning. We also have the dimensionality reduction, which is a technique used when the number of features used in a given data set is too high. So the dimensionality reduction is used to change this data set into manageable size and preserving data integrity. And this technique is applied using the linear projections approach. Now, when you go to the AI challenges that I faced in this project, we have insufficient data from which we have to obtain accuracy. This is because not every requirement is provided in the data set. You also have data sets being noisy and containing a lot of information. You have the bias problem whereby data is biased to one side. You have the data and storage issues, and that's also a challenge. Solutions, we have requirements engineering, which is the process that involves establishing and documenting requirements in the project. We have features engineering. Requirements engineering helps to solve data being less, not enough in the data sets we that use in this project. That's where requirements engineering comes in. And features engineering helps to solve the problem of the data sets being noisy or containing a lot of information, whereby it's the process of selecting, manipulating, and transforming those data into features that can be used in supervised learning or machine learning. And we also have understand your training data. Both academic and commercial data sets can have classes and labels that produce or introduce bias into This solves the bias problem, in other words, to understanding your trading data. We have differences between accuracy, recall, precision, and F1 score, which are the metric or valuation matrices in AI. Firstly, accuracy is the ratio of the total number of correct predictions to the total number of predictions, whereby accuracy is equal to true positives, whereby, okay, the TP is true positive, TN is true negatives, FP is false positives, and then we also have TN, which is true negatives, or false, and we also have FN, which is false negatives. We have what we call the recall, which is the ratio of the total number of correct predictions to the total number of correct predictions and incorrect predictions. And that is the formula, as you can see in my slides. We also have the precision metric, precision metrics, which is the ratio of the total number of correct predictions, the total number of correct predictions and false predictions. And that's the formula. We have the F1 score, which is the ratio of the product of the precision and recall to the sum of the precision and recall, multiplied by 2, and that's the formula of F1 score. And then the most appropriate AI evaluation metrics for the LPP system is the accuracy evaluation metric, which is the most recommended and appropriate AI evaluation metric for the laptop price predictor, which is LPP system, since it's all about the determination of which model is best for identifying peaks. As you have seen the formula for accuracy, true positives and then false positives over the total number or the total sample of the total sample. It's all about positivity. Okay, accuracy, positivity, the ratio of positivity, the positive results you've got from the AI project or the AI system you have created. And this helps to save time and bring about the most accurate results from the AI system, since it makes a search out of the variety and outputs the most recommended item from the many items included in the data set. It is got by the ratio as explained area of correct predictions to the total number of samples in the project. And as I conclude, I have the references that have helped me come up with this presentation. You can visit those or use those links provided in the reference list to get more details, because I was kind of brief, so sorry about that because of the time. But then you can kindly use those links to get more details of what I've not mentioned about in my presentation. And that's generally all about the LPP system. And a brief summary of all I've talked about: supervised learning, the unsupervised learning, true positives, true negatives, and that those are under the evaluation metrics, all matrices, whereby briefly supervised and under unsupervised learning, we have nothing to help us train the model. As unsupervised learning, we have nothing to help us train the model, but under supervised learning, we have to first train the model using dependent variables and independent variables, whereby the dependent variables are the outputs and the independent variables are the inputs. And these train the model on certain tasks. And under supervised learning, we have supervised learning uses experience, class of tasks, performance measures, and many more. Thanks. That has been the LPP system. Kindly subscribe to my channel.